Okay, let's start a new chapter. Non-parametric techniques, Tsquare test. The non-parametric techniques. Okay, the t-test, the ANOVA, one-way ANOVA, as they are all parametric techniques. They are all parametric tests. Now, today, we will learn how to use the non-parametric techniques. Okay, include the Tsquare, the Spearman's rank order correlation. Okay, firstly, let's look at Tsquare test for goodness of fit. Okay. Yes, for the t-test, also for ANOVA, the dependent variable should be considered as the normal distribution or close to the normal distribution. Okay, but if you have serious violation of the normal distribution, then the non-parametric techniques can be used. Okay. Yeah. Firstly, let's look at the Tsquare test for goodness of fit. This method is applied to test if the observed frequencies are the same as the expected frequencies. It's one of the most frequently used non-parametric test methods. Okay, so yes, please, firstly, you need to know that this Tsquare test is applied to test if the observed frequencies are the same as the expected frequencies. Okay, for example, let's look at the case 1. Okay. For case 1, the survey data of preference of 60 apparel consumers for long skirts. That means we will ask the consumer, if you like long skirt, if this consumer respond that like, then you will indicate 1. If these people choose dislike, then you will use the -1 to indicate. If this consumer answer undecided, then we will use 0 to indicate it. Okay, yeah, and then we will add how many people select like, how many people select dislike, and how many people they will select undecided. Okay, here totally 60 people respond. Like 80 people select like, 20 people select dislike, and 32 people they choose undecided. Okay, then firstly we needed to establish a fire. Here, look here, we have 2 variables. One variable is frequency, right? One variable is frequency. Another variable is preference. So here we have 2 variables. One is prefer for long skirt, frequency. Okay, now let's establish a fire. Okay, look at here. Let's fire new data, right? So we will establish a new data file. Okay, and then variable view here. Okay, x1. X1 label preference. Okay, preference. Okay, and then preference also here value 1, label like 0, undecided. -1, dislike. Add. Okay. Now x2. X2 is frequency. Okay. And here, measure. Preference is ordinal. Okay, frequency is a scale, right? Now, yeah, the variables are established. Next, we will put in data here. Here, x1 is the preference. So we have 1, which is like. How many people select like? 8. Second, dislike. The second is undecided. How many people? 32. Third, dislike. Okay, how many people? 20. Right? Okay, and then let's save. Okay, also, yes, please you too. Please save it. Okay, now here, I already have it, right? Okay, so give it a name and save the file. Are you okay? Are you okay? Okay. Next. Okay, so here, since it's the frequency, right? So it's special here. Okay, please look at the notes handout here. Yes, we define two variables, frequency, preference, and enter data. Yes, we have done this. Okay, so next step, we will weight cases. We will tell the program the data for frequency are in the form of frequency counts, not score. So we will use the weight case. Okay, options, data, weight cases. Click on weight cases by Yeah, for this, yes, to save the file, you can right now you can use save, okay? Because right now it has no file name, okay? If you revise your data, you want to change the former file, then you will use save. But if you will want to keep the former file, then you use save as. Now, because it's a new file, then you can just click save. Okay. But for a new file, both are okay. If you click save as, it's okay. Okay. Yep. Yeah. After you save it, yes, please let me know. Okay. Okay. Okay, so next we will weight case. Okay, so next I weight case, demonstrate how to weight case. Look at here. Yeah, to weight case. First, select data. Okay. Yeah. Look at the final weight cases, right? So click weight cases. Okay, weight case by. Weight case by. Here is a suggestion. Yeah, it's a command. Frequency variable. Which one is frequency variable? This one. Okay, so you will select frequency and then remove to this box. Okay, so frequency variable is frequency, which is x2. Okay, and then okay. So here you can see that weight by x2, right? So we finished the weight cases. Then now we finished the weight cases, right? We weighted. And next, let's do the Tsquare test. Okay, next we do the Tsquare test. Analyze non-parametric analysis Tsquare test. Okay, so here is the operation. Let's look at Analyze here. Also non-parametric tests. Non-parametric tests. Now, yes, please select legacy dialogues. And the first one, Tsquare. Okay, so here we will select Tsquare. Okay. Okay, which variable will be entered into the test variable list? Preference. Okay, please select frequency preference into the box. Okay. Now, next, look at here. Expected range, get from data, right? Expected value, all categories equal. So firstly, we want to test if all categories, if 3 categories equal, the frequency of 3 categories are equal, then yes, here is the default. Yeah, so we will test all categories equal or not first. We will keep it. Okay. Then, okay, then here you can see the result of Tsquare test here. Let's look at the result, analyze it, okay. Here is observed number, dislike 20, undecided 32, like 8. If the frequency of 3 categories are same, then expected number dislike 20, undecided 20, like 20. Here is the residue, 20 minus 20, 0. Observed number 32 minus 20, 12. Observed number 8 minus 20 minus 12. Okay, so if the residue can be considered as has no significant difference with 0, then we can say that the frequency of 3 categories has no significant difference, right? Okay, so here shows the residue, and here is the result of test. The Tsquare is 14.4. The corresponding significance is 0.001. So it means it's less than 0.01, right? So it's significant at 0.01 level. It's very significant. It means the frequency of 3 different categories have very significant difference. They are not the same. They are totally different. Okay? Yeah? Let's look at the analyze here. Yes, for this test, the null hypothesis is the frequency of the response categories are the same. But yes, for the result, from the result, it shows the Tsquare value is significant because the p-value is less than 0.05, or you can say it's the significance is 0.001, which is less than 0.01. They are okay. So it can be concluded that there are significant difference in the frequency of preference for long skirts. Okay. And also the results show that consumers are largely undecided on this issue. Okay, so that's the way you analyze it. Okay, got it. Okay, so next we want to test if the expected frequency look at here. Sometimes we would like to use the Tsquare test for goodness fit with unequal expected frequencies. Unequal. Okay, right now this one is the equal. This, yeah, we just finished if they are equal, right? And here we'll test if the data, yeah, if the frequency of different categories has unequal expected frequencies. Okay, for example, yes, we still continue to use these data, and please test if the frequencies for each category can be considered as 15, and 30. Okay, also you can say that it can be considered as 1, 2. Okay, so here is the hypothesis. If the frequencies can be considered as 15, and 30. Okay, so now still we will use we will use the same analyze. Look here, analyze here, right? And non-parametric test, legacy dialog, Tsquare. Analyze, non-parametric test, legacy dialogs, Tsquare. Okay, here the test variable is preference, right? And now, expected values, we will select values here. Okay, first one is 15, right? So we type in 15, add. Second, 15. Okay, add. And the third one is 30. Oh, I think here we need to change to 15, 30, 15, okay? Because I think I changed the sequence. Yeah, I changed the sequence. So here, yeah, we need to change. Yeah, remove it. Okay, 15, remove it. So here, value is 30. And the third value for the dislike, 15. Sorry. Yeah, because I use the new file, the new data file. It's different from the file we already established. Okay, here's the preference of long skirts, the former file. And now, when I type in, the sequence is different. So here I need to change. Okay, can you understand? Okay. Okay, so after we select the values for the expected values, then we click OK. Okay. Now, okay, so now look at here, the frequencies, the preference. Observed dislike is 20. Expected number is 15. I decided the observed number is 32 and the expected is 30. The observed is 8. Expected is 15. Okay, and here shows the residue. 5, 2, minus 7 is they are the residue. Okay, so we will test if the residue can be considered as 0, right? Okay, so you should understand this. Okay, next, here is the result of the Tsquare test. Here the Tsquare is 5.067 and the corresponding significance is 0.079. It shows it's more than 0.05. So we can conclude, it can be concluded that the preference of 3 different categories, their frequency can be considered as 15, 30, and 15. Okay, so that means the hypothesis is accepted. Okay, so that means the frequencies for each category can be considered as 15, 30, and 15. Okay, I told you because I changed the sequence. Okay, understand? Okay, got it. Okay, so we completed the first Tsquare test for goodness of fit. Okay, we will have a break. Okay, after 20 minutes, let me see. Yes, we will continue at 10:20. Okay.